Back before World War II, there was an old Prussian city called Königsberg that had two large river islands in the middle of the city. Legend has it that the people who lived in the city liked to go on Sunday walks, and a fun game was to try to cross all 7 bridges only once. Well, do you think it's possible? Well, my first attempt doesn't work because I end up stuck over here, and I still need to get to this bridge, but I've already used all 3 of these bridges. Nobody in the city could find a path that works, but when it comes to math shit, saying I can't do it and it's not possible are completely different things. One actually involves a proof. Well, lucky for Königsbergians, the famous 18th century mathematician Leonhard Euler lived nearby in St. Petersburg and reluctantly decided to come up with a proof. He recognized that a lot of the shit that usually matters in math is irrelevant here. It's a kind of geometry problem, but measurements, calculations, and even the sizes of land masses and bridges is irrelevant. So this is the same as this, and it's the same as this, which is just a graph. And check this out, each node or point on the graph has an odd number of connections. But once you get to one node, you have to leave by a different node, actions that come in pairs. So that means, with one exception, each node or landmass has to have an even number of connections. And this exception actually happened in World War II when 2 of the bridges were destroyed in air raids. If only 2 nodes have odd connections, you can start on one odd node and end on the other odd node. But if every point has an even number of connecting paths, then you can make what's called a Eulerian circuit by hitting every path and ending at your starting point. And coming up with this proof led to 2 fresh new types of math, graph theory and topology.